Hi, welcome to my video on given the value of a trig ratio, find the value of the other 5 trig ratios, part 2. Given the value of a trig ratio, let's do an example. Find the values of the other trig ratios if sine theta is 4 over 5. Well, first of all, sine is the y over the r on a circle, which comes from the opposite over the hypotenuse. And as a result, notice the sign is 4/5 and the 4/5 is positive. So we have a little chart that's called ASTC, or it could be the casserole, CAST, but I like ASTC gives you the positive trig ratios, and add sugar to coffee is the way I do it. So ASTC. If we did cast, it would be CAST, and A stands for all, sine, tan, cos. So sine is positive in quadrants 1 and 2. So let's draw a diagram for quadrant 1 and draw a diagram for quadrant 2. I'm doing 2 separate diagrams because there's 2 locations, and I want to make sure that you can see what we're going to do. So here's the 2 diagrams. So sine is sine theta is 4/5 in quadrant 1. So we'll draw a terminal arm. So that means this is the initial arm, this is the x-axis, this is the y-axis, this is the initial arm. So theta is the rotation that moves up to here. And so we drop a perpendicular to the x-axis. And because this rotation is theta, this angle in here is the reference angle, that's also theta. And sine is the y over the r. So the y is moving up on the right triangle. The r is the radius, which is 5. So we'll do the Pythagorean, and we'll work that out. Let's work it out down here. R squared equals x squared plus y squared. And 5 is the radius. And we want to find x, so y is 4. I put 4 in there instead of y. I could put x and y, but let's put the 4 here. And the 5, I put the y there. And 4 squared is 25 equals x squared plus 16. Leave the x squared where it is. It makes it a little bit easier to manipulate. We get a 9. We do the square root of both sides. And when we do the square root of the 9, we do plus minus. So x is plus minus 3. So we're in this quadrant, and notice that the x is 3 in this quadrant right here. X is positive. And let's look at where sine is also in the second quadrant, because add sugar to coffee. So sine is positive in 1 and 2. So let's draw the terminal arm in number 2. The rotation of theta here goes beyond. That's a 90. So it's more than 90 and less than 180. So that's the theta here. So we drop a perpendicular to the x-axis. And the y is moving up. So that's a 4. Hypotenuse, radius, hypotenuse, same thing, is 5. And we have to work out the trig ratio for here. Well, notice we're in this quadrant. These diagrams are similar. This is the reference angle right here. Even though theta is more than 90 and less than 180, it's the reference angle in the triangle between the terminal arm and the x-axis that determines the ratios, because that's the reference angle right there. This is the same size reference angle here because the 2 triangles are similar. And so in this diagram, x's on the left side, so the x is negative here. So that's when we do this, working out this Pythagorean here, we get the plus minus. So as you can see, because we have two locations, x is positive here and negative here. So sine for this one is still 4/5. For both of them are 4/5. But we want to find the other ratios, so we need to look at cosecant theta, reciprocal 5/4, and right here, cosecant, it's reciprocal, still 5/4. But the cos theta is the x over the r. Cos is x is 3, and the radius is 5, and the reciprocal of cos is secant, so that's 5/3. And in this diagram here, cos is the x over the r, which is the -3/5, and the secant theta is the reciprocal, -5/3, and the tan theta is, tan is the y over the x, so the y is 4 and the x is 3, so that's 4/3. So cot reciprocal is 3/4. And in this diagram, tan is still the y over the x, but this time it's 4/-3, which is -4/3. And cot is the reciprocal, so 4/-3 becomes -3/4. So we worked out, notice the difference between the first video on part 1 and this is part 2. In part 1, I gave you where to draw the diagram, one of these two, but here you have to put it in two locations because the trig ratio is positive in two quadrants and negative in the other two. Okay, practice. Practice means pause the video and see if you can work out the answers. Okay, as we did before, we have, this is tan, and tan is the y over the x on the circle, but tan is negative. So we're going to add sugar to coffee, add sugar to coffee, all sine tan cos. So what two locations do we have? Well, let's see. We have tan is negative. Tan is positive in 1 and 3. So tan is negative in 2 and 4. So let's draw a circle. And we go out in quadrant 2. We draw another circle. And we go out in quadrant 4. Again, tan is positive all. Tan, so 2 and 4. So let's draw it out in number 4. And that's the x-axis, that's the y-axis in each diagram. And alpha is the rotation from the initial arm, go right around till you get to that terminal arm. So that's alpha. But we drop a perpendicular to the x-axis. And the y is 15 and the x is 8. But notice, even though that's -15/8, it could have been 15/-8 because the fraction is negative. The negative could be in the denominator. But in this case, 15 and 8 are the y and the x, but the y is positive and the x is negative. And in this diagram, alpha is rotated right on around till we get to the terminal arm. There we go, right around. So notice alpha here is between 90 and 180, and alpha here is between 270 and 360. So again, we drop a perpendicular to the x-axis, and it says the y is 15, and the x is 8, and in quadrant 4, the x is positive, and the y is negative. So this time, it's 8 and -15, and notice the difference. Same value, both negatives, but the x's and the y's in each of these quadrants change signs. And so now we go and work out the Pythagorean this time. And we got to work out the, makes no difference which one you take. Take this one or this one. It's going to end up, because if you use 8 or negative 8, you're still going to get 64. If you use 15 or negative 15, you're still going to get 225. So r squared is 189. So the square root of r squared is plus minus the square root of 189. And the square root of 189 is plus minus 17. So that means the radius is plus or minus? No, the radius is always positive. So we put a 17 here and a 17 here. And just because alpha is this rotation, this angle right here, I call it the reference angle. That's the angle that determines the ratios. And in this diagram, the reference angle is right in this corner right here. That's the angle that determines the ratios. So tan for both of these is negative 15 over 8. Okay, and cot is reciprocal, negative 8 over 15. And that's true for both of these. 15 over 8. But let's determine what the sine is. Sine is the y. Let's take this, sine is the y over the r. So it's 15 over 17. So the reciprocal is cosecant. It's 17 over 15. And notice sine begins with s, so cosecant begins with c. So sine in this quadrant is the y over the x. So sine is the y. Sine is the y over the r. And that's negative. So that's negative 15 over 17. Notice that's a negative there. And the reciprocal of sine is cosecant. And so it's a negative 17 over 15. And cos theta, cos is the x over the r. It's a negative 8 over 17. X is negative 8 over r, which is the radius 17. And that begins with c, so I need an s, so that's secant. Theta is negative 17 over 8. And the cos, in this one, cos is the x over the r, so it's an 8 over 17. So secant is the reciprocal, is 17 over 8. So notice again that tan is negative in two quadrants, 2 and 4, so you had to work all of these out twice. And you notice that the values here are, these values are the same, but notice that these values are all the opposites of each other. That's a negative, and that's a positive, etc. That's a negative, that's a positive. Okay, and we have one more to do. Practice. Find the values of the other trig ratios if secant beta is a negative 13 over 12. Well, we got secant. Reciprocal of secant begins with s is cos. So cos beta is 12 over 13, and it's negative. I never put a negative on in the denominator, always in the numerators. So there's the reciprocal. And again, we have to deal with add sugar to coffee, add sugar to coffee, all sine tan cos. So now notice that I keep writing this out to explain it. So we went cos is negative, cos is positive in 1 and 4, so cos is negative in 2 and 3. So we have to draw our diagram in 2, and 3. Draw a circle. Draw a circle. Again, this is the x, and that's the y. That's the x, and that's the y. So we have to draw the terminal arm in quadrant 2. We have to draw the terminal arm in quadrant 3. And in both diagrams, we drop a perpendicular to the x-axis. And cos is the x over the r, or adjacent over hypotenuse. X is negative 12 over r is 13. And in here, x is negative 12, r is 13. And notice that this is beta, and it's in the second quadrant, so the rotation for beta is this. So beta is between 90 and 270, but it's the reference angle, this angle that determines the trig ratios. This is quadrant 3, so we rotate right around on the circle. And we come to this point, and so that's beta this time, so beta is between 180 and 270. But again, it's the reference angle, this angle that determines all the trig ratios for the rotation. And we have r squared is x squared plus y squared. So we have the radius is 13. We have the x is negative 12. So we have to find the y. 13 squared is 169. 12 squared is 144. So 169 subtract 144. Y squared. 25 y squared plus minus the root of 25 equals the root of y squared. Root of y squared is y, and we got a plus minus 5. Now, the y is negative and positive, so in this diagram, this y right here is 5, because it's positive, and this y right here is negative. So y is going up here, so y is positive. Just a little area there, so that's 5. And the y is going down here, so it's negative. So, and just, I forgot to mention that the coordinates of this point is negative 12, 5. And the coordinates of this point, x is negative 12, and the y is negative 5. Same coordinates, but they're positive minuses. I didn't do that in the other two. You could label, once you put this diagram in here in this circle and fill in these numbers, you can put the coordinates of x and y right there and in the other two diagrams also. So we have secant, which is what we're given. Beta is negative 13 over 12. So its reciprocal is cos beta, which is negative 12 over 13. And that's true for both diagrams. Negative 13 over 12, so we make that a 12. And cos beta is negative 12 over 13. So better be careful. Don't get sloppy. Sometimes you have a tendency to make errors. So this is cos. So let's do sine. And sine is the y over the r. So the y is 5 over the r is 13. So reciprocal is secant is 13 over 5. And we do sine for the other diagram in the other quadrant. Sine is the y, which is the negative 5 over the r, which is 13. The secant is the reciprocal, which is negative 13 over 5. Negative 5 over 13, negative 13 over 5. And we have to do tan. So the tan of theta. Tan is the y, which is the 5, over the x, which is the negative 12. So that makes it negative 5 over 12. Cot is the reciprocal. So cot is a negative 12 over 5. And we have to do tan for the other diagram. And tan here is, tan is the y over the x, so it's a negative 5 over negative 12. Tan is the y over the x, so that makes it positive. And cot is 12 over 5. And it makes sense. Notice that we talked about tan. Tan in this quadrant, tan is positive in 1 and 3, so it's negative in 2 and 4. Sorry, tan is positive in 1 and 3, negative in 2 and 4. So tan right here is positive in quadrant 3, but is negative in quadrant 2, which makes sense. Tan is negative in, this is quadrant 2, so tan is negative. And this is quadrant 3, and tan is positive. So everything works. And same thing. So notice the signs, positive, negative. Notice tan is negative. So when it switched to the other quadrant, it was positive. They switch. So even though I worked them all out, I could have done one of them. And then for these, this is true, whatever the sign is, but these signs change. So just working it reverse. And you have to learn the ASTC rule for positive and negative trig ratios. Very, very important, fast way to do it. If you like my video, click on the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.